What's the difference? In English, we use the word combination loosely without thinking if the order or things is important. In other words, my fruit salad is a combination of grapes, apples, and bananas. We don't care what order the fruits are in. They could also be bananas, grapes, apples, or grapes, apples, and bananas. It's the same fruit salad.
The combination to save is 472. Now we do care about the order. It's not 724 nor 247. It has to be exactly 472. When the order doesn't matter, it is the combination. When the order does matter, it is the permutation.
A permutation is an ordered combination. To help you to remember, think permutation, position. These are basically two types of permutation. Repetition is allowed, such as the lack above. It could be 3-3-3. No repetition. For example, the first three people in a running race. You can't be first and second. Permutations with repetition. These are the easiest to calculate. When a thing has n different types, we have n choices each time. For example, choosing 3 of those things, the permutations are n times n times n multiplied 3 times. More generally, choosing r of something that has n different types, the permutations are n times n quantity r times.
In other words, there are n possibilities for the first choice. Then there are n possibilities for the second choice, and so on, multiplying each time, which is easier to write down using an n times n times r times is equal to n raised to r. Example, in the lack above, there are 10 numbers to choose from. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And we choose 3 of them. 10 times 10 times 3 times equals to 10 raised to 3 equals to 1000 permutation. Where n is the number of things to choose from, and we choose r of them, repetition is allowed, and order matters.
So the problem is find the number of permutations of the letters of the word committee. So there are 9 letters of this, so it will become 9 factorial. However, we need to consider that the 2 m's are alike, the 2 t's are alike, and the 2 e's are also alike. So the permutation of 2m is 2 factorial, 2 t's is 2 factorial, and 2 e's are also 2 factorial. So our formula is p is equal to n factorial over p factorial, q factorial, and r factorial. So the number of the letter is 9 factorial. 9 factorial is equal to 362,880. While in here, 2 factorial is equal to 2. 2 factorial is equal also to 2. And 2 factorial is equal to 2. We need to multiply the 3 too. So 2 times 2 times 2 is equal to 8. So 362,880 divided by 8 is equal to 45,360.
Permutation without repetition.
In this case, we have to reduce the number of available choices each time. Example, what order could the 16 pool balls be in? After choosing, say, number 14, we can't choose it again. So our first choice has 16 possibilities and our next choice has 15 possibilities, then 14, 13, 12, etc. And the total permutations are 22,922,789,888,000. But maybe we don't want to choose them all, just 3 of them. And that is then 16 times 15 times 14 is equals to 3,360.
There are 4 checked and 3 slow walk books on the bookshelf. Checked books should be placed on the left side of the bookshelf, and slow walk books should be on the right side of the bookshelf. How many ways are there to arrange the books? So it is said, the problem that the 4 checked books should place in the left side of the bookshelf, while the 3 slow walk books should be placed on the right side. The permutation of 4 is equals to 4 factorial, and then the permutation of P3 is equals 3 factorial. 4 factorial is equivalent to 24. And 3 factorial is equivalent to 6. To get the final answer, we need to multiply the two given. So it will become 24 times 6 is equals to 144. The books can be arranged in 144 ways.
Combinations without repetition. This is how lotteries work. The numbers are drawn one at a time, and if we have the lucky numbers, no matter what order is, we win. Combinations with repetition. Now we can tackle this one. Let us say that there are 5 flavors of ice cream: banana, chocolate, lemon, strawberry, and vanilla. Think about the ice cream being in the boxes. We could say move past the first box, then take 3 scoops, then move along 3 boxes to the end, and we will have 3 scoops of chocolate.
The example for combination with repetition is, if there are 10 books in a shelf and you're going to pick 5 books from it, how many ways are you going to pick randomly 5 books from 10 books in a shelf? The formula of getting the combination with repetition is n factorial over r factorial, quantity n minus r factorial. And for our given example is there are 10 given books and 5 books that you're getting from the 10 books. For a given example, this is the formula, the 10 factorial over 5 factorial, quantity 10 minus. First of all, you need to get the one that is inside the parentheses. Then you'll get 10 factorial over 5 factorial times 5 factorial. If you substitute the 10 factorial, it will be 3,628,800, while the 5 times 5 factorial is 14,400. If you divide the two, you'll be getting 252 ways of getting 5 books in a 10 books in a shelf.